Have you ever looked up at the night sky and wondered what's really out there, hidden behind the twinkling stars? What if I told you the universe is filled with a mysterious substance? A kind of fog that obscures our view of distant galaxies and newborn stars? This isn't just any fog, it's cosmic dust. And today we're diving deep into what it is, where it comes from, and how the incredible James Webb Space Telescope is giving us an unprecedented look through this celestial veil. Let's start with what we're up against. Imagine massive pillars of dust and gas stretching for over 1 billion kilometers through space. These are the famous pillars of creation, and they're just one example of the cosmic dust clouds that fill our universe. For telescopes like the Hubble, this dust is a major obstacle. It's like trying to take a picture of a mountain on a foggy day. The details get lost. This dust scatters and absorbs visible light, hiding some of the most fascinating events in the cosmos, like the birth of stars and the formation of new solar systems. But this is exactly where the James Webb Space Telescope, or JWST, comes in. It's designed to see the universe in a different light, quite literally. So what exactly is this cosmic dust? When you think of dust, you probably picture the stuff that gathers on your bookshelf. But cosmic dust is a completely different beast. It's made of incredibly tiny solid particles, some just a few molecules in size. These particles are a mix of elements like carbon, silicon, magnesium, iron, and oxygen. They're essentially the microscopic building blocks of the universe, floating through the vast emptiness of interstellar space. And there's a lot of it. Scientists estimate that about 4,700 metric tons of this cosmic material falls to Earth every single year. Imagine that. Every day, remnants from comets and asteroids are raining down on us, mostly burning up in our atmosphere as shooting stars. But while we can measure what lands on our planet, figuring out the total amount of dust in the entire universe is a monumental challenge for astronomers. Where does all this dust come from? The main factories for cosmic dust are dying stars. When a massive star reaches the end of its life, it goes out with a bang in a spectacular explosion called a supernova. This explosion is so powerful that it forges new, heavier elements inside the star's core and then blasts them out into space. Elements like carbon, oxygen, and iron, the very stuff that makes up our planet, and even our bodies, are scattered across the galaxy. As this ejected material cools, it clumps together to form tiny dust grains. Other less dramatic stars, like our own sun, will eventually also contribute. As they age, they gently puff their outer layers into space, enriching the cosmos with dust. So in a very real sense, we are all made of stardust. This dust isn't just cosmic debris. It's the raw material for future generations of stars and planets. This brings us to why cosmic dust is so incredibly important. It's not just getting in the way. It's a vital ingredient for creation. In those dense, dusty clouds, gravity slowly pulls particles together. Over millions of years, these tiny grains stick to each other, growing into pebbles, then boulders, and eventually forming entire planets, moons, and asteroids. Without cosmic dust, there would be no rocky planets like Earth. These dusty regions are cosmic nurseries, where new solar systems are born. This is why peering through the dust is so critical. We want to witness this process of creation as it happens. We want to see how planets form around other stars and understand the origins of our own solar system. This is where the James Webb Space Telescope truly shines. Unlike Hubble, which primarily sees the universe in visible and ultraviolet light, JWST is designed to see in infrared light. Think of it like this. Visible light has a hard time passing through thick dust clouds, just like your car's headlights struggle in dense fog. But infrared light can penetrate these clouds much more easily. It's like having a special pair of goggles that let you see through the fog. By detecting the faint heat glow of objects hidden behind the dust, JWST can reveal a universe we've never seen before. It can show us newborn stars still wrapped in their dusty cocoons and give us a glimpse into the cores of distant galaxies. One of JWST's most stunning achievements is its re-imaging of the pillars of creation. Where Hubble saw opaque, dark columns, JWST's infrared view peels back the layers, revealing countless young stars forming within the pillars themselves. We can see bright red, fiery points of light. These are baby stars, just a few 100,000 years old. It's a direct look into a stellar nursery. By studying these images, astronomers can learn more about how stars gather mass from the surrounding gas and dust, and what happens when their powerful stellar winds start to blow that material away. It's a dynamic, ongoing process, and JWST is our front row seat. This telescope isn't just taking prettier pictures. It's fundamentally changing our understanding of star and planet formation. But JWST's capabilities go even further. By analyzing the infrared light that passes through the atmospheres of exoplanets, planets orbiting other stars, the telescope can detect the chemical fingerprints of different molecules. This is called transmission spectroscopy. It allows us to figure out what an exoplanet's atmosphere is made of. Are there signs of water, methane, or carbon dioxide? The presence of these molecules could be tantalizing clues in the search for life beyond Earth. Cosmic dust plays a role here too, as dusty or hazy atmospheres can affect what we're able to detect. Understanding the properties of this dust helps scientists more accurately interpret the data and get a clearer picture of these alien worlds. Looking back at the big picture, cosmic dust is both a challenge and a key. It's a veil that has hidden much of the universe from our view, but it's also the very substance from which worlds are made. For centuries, we've looked at the night sky and seen the gaps between the stars as empty darkness. Now, thanks to the James Webb Space Telescope, we know that these dark patches are teeming with activity. They are the birthplaces of future stars and the reservoirs of raw materials for new planets. JWST is not just an observatory, it's a time machine. Because light takes time to travel, when we look at distant objects, we're seeing them as they were in the past. JWST can see so far that it can look back to a time when the first stars and galaxies were forming. Just a few 100 million years after the Big Bang, it's helping us piece together the complete history of our universe, from its earliest moments to the present day. So the next time you look up at the night sky, remember that there's so much more than meets the eye. Hidden within those dark patches are swirling clouds of cosmic dust, the building blocks of everything we know. And thanks to the incredible power of the James Webb Space Telescope, we are finally pulling back the curtain and witnessing the grand, dusty, and beautiful process of cosmic creation. The universe is revealing its secrets, one infrared image at a time, and it's more spectacular than we ever could have imagined. Thank you so much for joining me on this journey through the cosmos. If you found this as fascinating as I do, please hit that like button and subscribe for more deep dives into the wonders of our universe. Let me know in the comments what you think is the most exciting discovery from JWST so far. Until next time, keep looking up.